Assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Okay guys, we are solving problem 25 of chapter 22. First of all, let's see what the problem is asking for. We have to write the formula for each complex ion or coordination compound. So if we have a complex ion, we will have a central metal bounded to ligands and a certain total charge. If we have a coordination compound, other than the metal and the ligand, we will have a counter ion that will balance the charge of the complex ion. So we will define this number of the counter ion based on this charge. Let's see the first example. Let's identify first the metal and the charge. In this case, the metal is the chromium. So we write down Cr. We know from the periodic table that this is the symbol. And the charge is indicated here, so it's +3. Then we identify the ligand and the charge. In this case, the ligand is the hexaamine. So hexa stays for 6 and amine stays for ammonium ligand. The ammonium ligand has charge of 0, so it's neutral. And overall, we have 6 ammonium for a total charge of 0. You have a ligand list in your book at page 991. So now we are ready to write the final formula. We write down first the metal, followed by the ligands, and then we need to find out what the final total charge is. We said that the ammonium ligand has no charge, so the only charge we have in here is coming from the metal, that is +3, and we write it here at the end, outside the brackets. So now let's apply the same approach for all the other example, and let's see if there's anything different. In this case, again, let's identify first the metal atom, that is the ferrate, and the charge that is 3+. So we write down Fe +3. Then let's find what the ligand is. Hexacyano. Hexa stays for 6, and the cyano ligand we can indicate it with Cn. Each cyano ligand has a charge of -1. So overall, we can write down Cn6, and the total charge is going to be -6. In this case, as you see, we also have a potassium that is acting as a counter ion. So potassium we can indicate with K. Each potassium has a charge of +1. So we will need to find out how many potassium we will need to balance the total charge of the complex ion that is formed by the metal plus the ligand. So we can write down the final formula with the potassium at the beginning. Then in brackets, in the square brackets, we write down the metal, Fe, with the corresponding ligands, Cn 6 times. Now, we know that the Cn6 has a total charge of -6. The metal has a total charge of +3. -6 plus 3, it gives -3. Each potassium has a charge of +1, so we will need in total 3 potassium in order to balance the charge of the complex ion. Let's move to the next example. Okay, let's identify the metal first, copper, and the charge, 2+. So we write down Cu +2. Then in this case, we have 2 different type of ligands. Let's write down here the first one. As you see, they are listed in alphabetical order, and also in your formula you will follow the same order. So let's start from the first one. You will see from the table at page 991 that this ligand we can indicate as En, and thus charge 0. So no charge is coming from this ligand. The second ligand The dye stays for 2, and thiocyanate is SCN. Each thiocyanate ligand has a charge of -1, so overall we will have 2 of them for a total charge of -2. Now we can write down the final formula starting with the metal, the first ligand, the En, and the second ligand, 2 times, as we see from here. Now, the final charge is the result of the charge coming from the second ligand, -2, and the metal, -2 plus 2 equals 0. So we have no charge outside the brackets. Let's move on to the last example. So in this case, we have 2 times the metal, platinum 2, platinate 4, with the corresponding ligands, tetraaquaplatinum, hexachloro. Let's start from the first one. So let's identify the first metal, platinum 2. So we write down Pt with the charge of +2. The associate ligands is the tetraaquaplatinum. Tetra stays for 4. Aqua is the ligand, is water, H2O, and has a formal charge of 0. So overall we will have 4 water ligands, H2O4, with no charge. Let's move on to the second part of the compound. Platinate 4 is the second metal atom, so Pt, with a charge of +4. The associate ligand is the hexachloro. Again, hexa stays for 6, chloro is the ligand, and we can indicate it as Cl. Each Cl ligand has a charge of -1, so overall we will have Cl 6 times for a total charge of -6. Now we can write down the final formula. Since we have 2 times the metals with 2 different ligands, we write down in 2 different, we separate in 2 different brackets. So let's start with the first one, platinum, together with the corresponding ligands, the water ligands, 4 times. With a total charge of +2, because we said the water has no charge, while the platinum has charge +2. The second, we list the platinum again with the corresponding ligands, the hexachloro, so chloro 6 times. And we said that 6 chloro has -6 charge. This platinum has +4, so -6 plus 4 is -2. Now we see we have a formal charge of -2 here and +2 here, so overall we can cancel them out and the total charge is gonna be 0.